These are your notes for Unit 11, Day 5 of Pre-Calculus. If you would like to see your warm-up, review question, or any homework questions we covered in class today, just look at the finished notes. So today we are going to talk about non-linear systems of equations. So equations that could make your conic sections, and we're going to learn how to solve them by graphing, substitution, and elimination. And then we're going to talk about how to graph a linear inequality and a system of linear inequalities, or nonlinear inequalities as well. So solve a nonlinear system by graphing. So if we have the two relations, x squared plus y squared equals 9, that's a circle. The center of that circle is 0, 0, and the radius is 3. So we're going to start. We'll make the center at 0, 0, then up 3, to the left 3, to the right 3, and down 3. And then we're just going to make our circle through those 3 points. And so that's your circle with a center of 0, 0 and a radius of 3. And the second one is a line that starts at -2, and then it goes down 3 and over 1. And then we can connect that line. And so the solutions to the system would be where the line and the circle intersect. So at that point and that point, we can estimate those solutions, or we can go on Desmos and find their actual solutions. So x squared plus y squared equals 9, and y equals -3x minus 2. So we've got our circle and our line, and they intersect at the points -1.527, 2.582, and 0.327, and -2.982. So we can estimate by graphing by hand, or we can use Desmos to find the exact solutions. All right, we can also solve a system of nonlinear equations using substitution. So you want to solve for x equals, y equals, or sometimes you can either get x squared or y squared by itself, depending on the equation that you're given. Well, in this equation, we have 3x minus y equals -2, and I have 2x squared minus y equals 0. Well, notice that both of the equations have y's. So I'm going to solve that top equation for the y. I'm going to get that y by itself. So I'm going to add the y over. So I have 3x equals -2 plus y, and then I'll add the 2 over. So 3x plus 2 equals y. And now I can substitute that value, 3x plus 2 equals y, into my second equation. So my second equation is going to become 2x squared minus 3x plus 2 is equal to 0. Now I have one equation in one variable. So distribute the negative. So 2x squared minus 3x minus 2 equals 0. And now I'm going to factor by grouping. So 2x squared multiply to -2 and add to -3 would be -4x and +1x, then minus 2 equals 0. Group the first 2, group the second 2, plus sign in the middle. I'll factor out a 2x, and I would get x minus 2, and I'd factor out a 1, and I'd get x minus 2 equals 0. So I have 2x plus 1 times x minus 2 equals 0. So my x value is either -1/2 or my x value is 2. Since it was a system of equations, we're not done. We have to find the y values that correspond to each of those x values. Well, I know that y is equal to 3x plus 2 from up above. So if I take 2 and plug that in, I would get to be 8. So I know the point 2, 8 is a solution to my system. And if I plug in -1/2, 3 times -1/2 is -3/2 or -1.5. And -1.5 plus 2 is 1/2. So I would also have the point -1/2, +1/2. We can check by graphing. So if I were to graph those two relations on Desmos, so 3x minus y equals -2. 3x minus y equals -2. And 2x squared minus y equals 0. They would intersect at the point -1/2, 1/2, and 2, 8, which is exactly what we got when we solved using substitution. You can also solve using elimination. To solve using elimination, you need to eliminate one of the variables. So I need everybody to line up right now. So I have x squared plus y squared equals 13. And then notice that bottom equation has a y and the top equation doesn't just have a y. So I'm going to put a 0y in as a placeholder. So when I subtract, I have my like terms on top of each other. So I have x squared I have no y squareds, I have a minus 1y, and I have a 7. Some of you guys will be able to keep track of that in your head, but if not, you can replace anybody who's missing with a 0 of that term. And now to eliminate, I'm going to subtract all the like terms. Y squared minus 0y squared is y squared. 0y minus negative y is positive y. And 13 minus 7 is 6. Okay, I'm going to subtract the 6 over, and I'm going to solve that by factoring. So y squared plus y minus 6 equals 0. This would be y plus 3 times y minus 2 equals 0. So y is either negative 3 or y is 2. I'm going to use that bottom equation, x squared minus y equals 7. And so I get x squared, and then if I plug in negative 3 for y, I get plus 3 equals 7. So x squared is going to equal 4, so x is going to equal plus or minus 2. So I have the point 2, negative 3, and negative 2, negative 3. So that negative 3 is going to give me two solutions, 2, negative 3, and negative 2, negative 3. If I plug in the 2, x squared minus 2 equals 7. Add the 2 over, and I get x squared equals 9. So x would equal plus and minus 3. So those two solutions would be 3, 2, and negative 3, 2. So notice this system of equation has 4 solutions. So those two graphs should intersect 4 times. Well, let's check on Desmos. So my relations are x squared plus y squared equals 13. So that's going to make a circle. And then I have x squared minus y equals 7. That's going to make a sideways parabola equals 7. Or sorry, an up and down parabola. And so now we have the point negative 3, 2, 3, 2, negative 2, negative 3, and 2, negative 3, which is exactly what we got as our solutions when we solved using elimination. All right, let's look at these two. X squared minus y squared equals 4, and y equals x squared. Well, notice I have y is equal to x squared. Since I have x squareds in both, I can replace that x squared in my top equation with the y. So I have y minus y squared equals 4. Add everybody to the other side, so 0 equals y squared minus y plus 4. Can I add to 4 or multiply to 4 and add to negative 1? No, so I would have to use the quadratic formula to solve this. And so y is going to equal the opposite of b. So it's going to equal positive 1 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. But notice I'm going to have imaginary terms. So this should have no solutions because I get imaginary values for my y. So if I graph these two, they should not intersect. And so if I graphed x squared minus y squared equals 4, this is going to give me a hyperbola. And then if I graph y equals x squared, notice these two graphs never intersect. So like I said, this would have no solutions when I tried to solve using substitution. Let's look at our next one. X squared plus x plus y squared minus 3y plus 2 equals 0, and x plus y squared minus y over x equals 0. All right, this one looks ugly. How should we go about solving this one? I'm going to get everybody, I'm going to multiply everybody in that bottom equation by x. As long as x doesn't equal 0, this would work because if x was equal to 0, you'd get 0 in your denominator. So we get x squared plus y squared minus y equals 0. And then that top equation is x squared plus y squared minus 3y. And then I'm going to subtract that 2 over equals negative 2. Now notice what happens if I were to subtract these two equations, all of my x terms would go away. So I get x squared minus x squared is 0, x minus x is 0, y squared minus y squared is 0, negative y minus negative 3y is 2y, and 0 minus negative 2 is 2. So I get y equals 1 is my only value for y that would work. If I took 1 and plugged it in, let's plug it into the top one. So x squared plus 1 squared minus 3 times 1 plus 2 equals 0. So I get x squared plus x equals 0. Factor out an x, and you get either x is 0 or x is negative 1. So my solution should be 0, 1, and negative 1, 1. All right, let's graph these. Oh, but remember, x can't be 0. I forgot to check. So this one should not actually be a solution. So my only solution should be negative 1, 1. Well, let's graph these on Desmos and see what happens. So we get x squared plus x plus y squared minus 3y plus 2 equals 0. So that is a very little circle. And then I get x plus 1 plus, then parentheses, y squared minus y. And then that is divided by x equals 0. Let's do home, so let's blow this up. Oh, I do have two solutions. So I've got a solution at 0, 1, and negative 1, 1. Huh. So x equals 0 actually worked. Well, it's a good thing that we checked. I'll have to look into why that works. But those would be our two solutions. All right, let's look at our next one. 3xy minus 2y squared equals negative 2, and 9x squared plus 4y squared equals 10. All right, so we need to eliminate either our x's or our y's. What should we do here? We want to solve for x. Let's just solve this by graphing. So if we were to solve this by graphing, we would have 3xy minus 2y squared equals negative 2. And we have 9x squared plus 4y squared equals 10. And so these would have 4 solutions. And so if we solve this by graphing, we get solutions 1, negative 1/2, 1 positive 1/2, I believe is negative 1, positive 1/2. And then we get 0.471, 1.4142, and negative 0.471 and negative 0.1441, or negative 1.4142. So we'll just solve that one by graphing. All right, so how do we graph linear inequalities? So just to review, so if we had something like y is greater than 1/2 x minus 3. So first graph the boundary line. So negative 3 is the y-intercept, up 1/2. If it is in less than or greater than inequality, linear inequality, it's going to be a dashed or dotted line. If it's less than or equal to, greater than or equal to, it's going to be a solid line. Since this one is just greater than, we're going to make a dotted line. And you've got two options. You could do a test point. So we could test the point 0, 0 and see if it's part of the solution. So if I plugged in 0, is 0 greater than 0 minus 2? It is, so I would include 0, 0 in the shading. Or if y is greater than the line, you would shade above the line. If y is less than the line, you would shade below the line. Well, notice it's saying y is greater than my line. So where is y greater than that line? It would be above, so I'm going to shade above the line. If we had something like 2x minus 3y is less than or equal to 9, first we would solve for y, so subtract the 2x, subtract the 2x, and we would have negative 3y is less than or equal to negative 2x plus 9. Divide everything by negative 3, and remember when you divide by a negative, flip the inequality sign, so we have y is greater than or equal to 2/3 x minus 3. So start 3 down and then go up 2/3. This time it's going to be a solid line. And again, y is greater than that line, so we would shade above the line. If it was just x is less than 2, that is going to be a vertical line where x is equal to 2, and it's going to be a dotted line. And since x is less than 2, you would shade where x is less than 2, and so it would be to the left. Or if you had a horizontal line, like y is greater than or equal to 1, that would be a horizontal line where y is equal to 1, and it would be a solid line. And then it's saying y is greater than that, so you would shade above that line. Graphing nonlinear inequalities. Well, again, instead of graphing your boundary line, you would graph the boundary shape. So x squared plus y squared equals 4 is a circle. The center of that circle is 0, 0, and the radius of that circle is, 2. So 0, 0, and then up 2, right 2, left 2, down 2. It's or equal to, so it's going to be a solid circle. And we're saying that the radius is less than or equal to 4. So you can do a test point. So if we tested the point 0, 0, would it work? Is 0 plus 0 less than or equal to 4? It is. So we're going to shade inside my circle. And yes, Desmos can do this. So if we were to graph x squared plus y squared is less than or equal to 4, notice we would have a circle with a solid line around it, and you would shade inside the circle. Okay. Graphing systems of inequalities. So you would graph them each, and where their shading overlaps is your solution. So solve the first one for y. So we have y is greater than negative x plus 2. So we would start at positive 2 and then go down 1 over 1. It's going to be a solid line, and then it's saying y is greater, so we would shade above the line. And then solve the next one. We have negative y is less than or equal to negative 2x plus 4. Divide everything by negative 1, so the sign flips. And we have y is greater than or equal to 2x minus 4. So 4 down, 1, 2, 3, 4, and then up 2 over 1. And again, this is going to be a solid line. And you are shading above the line again, so everything above the line. And then my solution is where those shadings overlap, so you can erase the rest of the shading where they're not overlapped. And so my solution is up in that upper piece. All right. Why don't you guys pause the video and try the second one. X plus y is less than or equal to 2. X plus y is greater than or equal to 0. All right, so we have y is less than or equal to negative x plus 2. So 2, and then down 1 over 1. It's a solid line, and then you're going to shade below it because y is less than. And then on the next one, y is greater than or equal to negative x plus 0. So we would start at 0, and then we would go down 1 over 1. And again, it's going to be a solid line. Notice these two lines are parallel, and y is greater than, so we would shade above it. So my solution is going to be in between those two lines. So it's that single slice between those two lines would be my solution. All right, why don't you guys pause the video and try A and B, and you can check your work against the finished notes from class today. All right, what if we have a whole big thing like x plus y is greater than or equal to 3, 2x plus y is greater than or equal to 4, x is greater than or equal to 0, y is greater than or equal to 0. So the solution is going to be where all 4 shadings overlap. So if I solve the first one, y is greater than or equal to negative x plus 3. So, and then down 1 over 1, it's going to be a solid line. We're going to shade above that line. And then the next one is going to be y is greater than or equal to negative 2x plus 4. So this one's going to start at 4. And we're going to go down 2 over 1. And then it's going to be a solid line. And we're going to shade above. So above that line would be here. And then y is greater than or equal to 0, x is greater than or equal to 0. Well, here is where y is equal to 0. And so we're going to shade above that line. And then where x is greater than or equal to 0, there's where x is equal to 0. And then greater than or equal to 0 would be in the first quadrant. So where the shading overlaps, let's erase. So we'll erase in here, we'll erase in here, erase in there, erase down here, erase down here. So my solution is going to be up in that area where all of the shading overlaps. All right, let's see if it's a non-linear system. So y is greater than or equal to x squared minus 4. So that is a parabola that moved 4 down. So 1, 2, 3, 4. And then it would have x-intercepts at 2 and negative 2. It's a solid parabola. And we're saying that y is greater than or equal to, so we could test the point 0, 0. So is 0 greater than or equal to 0 minus 4? It is. So we want to include 0, 0, so we're going to shade the inside of this parabola. And then x plus y is less than or equal to 2, so y is going to be less than or equal to negative x plus 2. So start at 2, and then down 1 over 1. And it's going to be a solid line. And y is less than, so we're going to shade below the line. So my solution is going to be that little part of the parabola right there. So we can erase this shading up here. And that would be my solution. So if we went onto Desmos, we could show that this would be right. Y is greater than or equal to x squared minus 4. And then we have x plus y. Yep. X plus y is less than or equal to 2. And so notice my answer is going to be where those two shadings overlap, which is what we have. All right, your homework is 11.6 and 11.7.